Hello, everyone. So we're going to do a bit more revision. I found these couple of questions. These are from the last few years' papers on coordinate geometry of the line, specifically the line. A lot of times these are mixed up with coordinate geometry of the circle, but these ones are particularly of the line. So the first one, and again, pause at any stage, try the question, come back into the video and see how it's done if you think you got it right or wrong. The line P intercepts the x-axis at A 0. And intercepts the y-axis at 0b, where a and b are not equal to 0. Fair enough. Show that the equation of p can be written. So remember, equation is y minus y1 is equal to m on x minus x1. So in order to get this right, we need one of these coordinates for the x1, y1, and we need an m value. So let's start by getting the m value. Okay, that's x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So that gives me a slope of minus b over a. Okay, it's b over minus a, but minus b over a is better. So we have everything we need now. So let's do our formula. So we have y minus y1 is 0. It's equal to m on x minus x1, which is a. I have to distribute the a. Okay, ay is equal to minus bx plus ab. Okay, so they want us to rearrange it to have the x's and the y's on one side and the whole number on the other side. Let's do that. So bring that over. That's going to be bx plus ay is equal to ab. Now, how the hell do we get it to this? Well, if I look at this one, that's 1, which means this had to turn into a 1. So if I divide everything by ab, let's see what happens. This divided by AB, well, the b's a cancel, okay? And you'll have x over a plus y over b is equal to ab divided by ab is 1. Have we got what we want? We sure do. Okay, that one's done. Now, let's have a look at the next bit of this question. The line L has a slope of m and contains the point 60. Write the equation of the line L in terms of m. Okay, well, again, we can use our formula. Y minus y1 is equal to m on x minus x1. So we have a point of x1, y1. So y minus 0 is equal to m on x minus 6. Y is equal to m on x minus 6. So that's technically the answer. If we want to multiply it out, mx minus 6m, you can do that as well. Makes no difference really. It's probably easier if you just want to identify the I'm sure there's going to be something else later on in the question, but that's basically it. Nothing else to it. They're both correct technically, so either of them will do fine because you're given it to in that form. Y is equal to mx plus c type of thing. So next bit of the question. Let's see what they're asking. Aha. The line L cuts this at P. Find the coordinates of P in terms of M, and then give the coordinate. Okay. Right. So if you think about what they're asking you to do here, it's a bit more kind of convoluted, for want of a better word. So they want you to get sub one into the other, that type of idea. So let's try that. So we have from part 1, we have y is equal to mx minus 6m. Okay, we're going to substitute that y value into, 3y plus 4x equal to 25. So what we're going to do is we're going to substitute that y in there, then solve it for x, substitute it back in and solve for y. Okay, that's the idea. So let's give this a go. We're going to solve for x. So 4x plus 3 times mx minus 6m equal to 25. Let's make this a bit nicer. That's 4x plus 3mx minus 18m equal to 25. Let's rearrange it to get x on its own. So that's 4x plus 3mx is equal to 25 plus 18m. Factorize out the x from here. 4 plus 3m equal to 25 plus 18x. That means x is equal to 25 plus 18x over 4 plus 3m. Sorry, it's gone down to the bottom of the page. Hope you can see that there. Okay, so just keep factorizing until I get what I want. So there is x. It's in its simplest form. I can't make that any simpler. So now we're going to have to substitute it back into this one. So now it's going to be y equal to m times 25 plus 18x over 4 plus 3m minus 6m. Okay, so we'll do this in stages. First of all, we'll get this distributed across, and then we'll factorize. We'll get a lowest common multiple and make it one fraction. So y is equal to 25m plus 18mx over 4 plus 3m minus 6m. So y is equal to common denominator 4 plus 3m. Now, that into that goes once, so this top line stays the same. However, that's over 1. That into that goes that time. So minus 24, let me think, minus 24m minus 18m squared. 18m squared. Okay. Oh, look what I'm doing here. Just notice that it's an m there. That's an m. It's an m. That's an m squared. I don't know where the x is coming from. That's a squared, because I'm just thinking it's going to cancel, isn't it? Minus 18m squared, because that times that give you minus 18m squared. So y is equal to m. 25m minus 24m is m over 4 plus 3m. So my coordinates are 25 plus 18m over 4 plus 3m, and then m over 4 plus 3m. And that's a bit of a hefty one, okay? So just be careful of that one, rewind it. I made a little mistake there. I just spotted it when I was, because I figured that why would it be an m squared if there wasn't one to cancel with it? And you can see where my mistake was. When I was here, that was an m, and for some reason I made it an x. I don't know what I was thinking. And then I followed the x all the way down, but I spot mistake there. Thanks to God. Right, that's that one done. Ooh, the next one. Okay, I like these ones. These are more of my synthetic ones. Okay, so we've got 3 points on a triangle. Find the equation of the line perpendicular to AC. So it's some line that goes there that way. Okay, so that's really what we're looking for. Some line that kind of pops down through that there. Okay, so I suppose, listen, let's try and let's be cheeky with this. Just for the crack, let's just throw in a number here. I'm just doing this just purely for the visuals. Okay. Something like that. Something like that. That's what we're looking for. So what do we need? We need the slope of this, and then we'll get the slope of that. It's pretty easy. Then we'll use the point B. So we need 5 and 3 as my x1, y1. And then my slope is going to be what I've A and C. Okay, so I'm just going to get x1, y1, x2, y2. So it's going to be y2, so that's minus y1. So 4 minus 2, which is 6 over x2 minus x1. 6 over 5. So that's going to be, let me think now, that's going to be 3 minus 2 over 3, and then perpendicular, that's 3 over 2. Okay, 3 over 2 is slope of this one. So y minus y1 is equal to m on x minus x1. Bottom left, top right, 2y minus 6 is equal to 3x minus 15. Bring it all together. 3x minus 2y minus 9 equals 0. So that's 3x minus 2y minus 9 equals 0. Okay, so that's a pretty straightforward one. I hope you can all see that. Now, I suppose this is the tough bit. Use your answer to find the coordinates of the orthocenter. The orthocenter is found by getting two perpendiculars and finding their intersection. So I have one of these perpendiculars. So if you would just, we're going to visualize this. There's one of them. Let's extend it on a bit. So the problem is you can see here that any perpendicular line drawn on this one, so I'll try and visualize it again. Any perpendicular line to this is going to have to come out this way, somewhere this way, if you know what I mean. So what we're looking for is, I'm going to predict the answer already. The answer is going to be 7, 6. Okay, you can see that. Okay. I'm going to predict a 7, 6 type of situation here. Okay, because if I extend AB onwards, there's your perpendicular. And the only place that the two of them meet is around 7, 6. Okay, so let's try and figure it out though from the mathematique. How do we find it from the maths? So what we need to do is we need to get the equation of AB, get the slope of AB, perpendicularize it, and then use it with the point C to get an equation for this line. And then the intersection of this line and this line will give me that point. Sorry. So just go up there. So here's our kind of problem. AB extended on can give me a slope. I can get the slope of this line. That means I can get the slope of this line because it's perpendicular. Once I have the perpendicular slope with the point C, I'll get the equation of this line. And then if I intersect the equation of this line with this line, I'll get this point. That's my plan. So let's do that. The slope of AB. So AB is 6 and minus 2 and 5 and 3. So the slope is minus 5. Let's say 3 plus is 5. Yeah, slope is minus 5, which means the perpendicular slope is 1/5. That's the one I want. So C is minus 3 and 4, x1, y1, and then my slope is 1/5. So what have we got here? We have y minus y1 is equal to 1 over 5 on x plus 3. That's 5y minus 20 is equal to x plus 3. Let's rearrange it and make it nice. That's x minus 5y plus 23 equals 0. So there's my other fella. So now let's put the two of them together. Okay, so there's my other equation. I'm going to put it together with the equation I have already. Let's pop them up here together. 3x minus 2y equal to 9 and x minus 5y equal to minus 23. Simultaneous them, multiply the bottom line by minus 3. That should cancel out the x's. So that's going to give me minus 3x plus 15y equal to 69. Right, so how does that cancel with this one? That's gone with that. You'll get 13y is equal to 78. And would you believe y is equal to 6? We said y was going to be equal to 6, didn't we? Right here, up here in the corner, sorry. Up here in the corner, we said y was going to be equal to 6. So listen, we already know x is going to be equal to 7 because it has to be. So 7 and 6 is the orthocenter. Okay, cool. A bit tougher, that one. Now, what's next? Ooh. Okay, so we're on to the tough one now. So have a look at this one. Look at that. A bit more space on this one. So show that for all k an element of the real number, this point is on this line. What do we know? If a point is on a line, then if you substitute it in, you get 0. Let us see if this is true. That's x1, that's x, and that's y. So if I put 3 times 4k minus 2 minus 4 times 3k plus 1 plus 10, I should get 0. Okay, so that's 12k minus 6 minus 12k minus 4 plus 10 equals 0. 0 equals 0. Therefore, P is on L1. Okay, done. The line L2 passes through P and is perpendicular to L1. So it passes through P and it's perpendicular to L1. Find the equation of L2 in terms of K. Oh, okie dokie. Right. So what we need to do is find the slope of L1, get the slope of L2 because it's perpendicular. That's easy enough. And we're going to use this point to help us. Okay, so let's write down this point again. This is x1, y1. So we have 4k minus 2, and we have 3k plus 1. So there's my x1 and y1. I'm just parking them there. Now slope. First of all, we need the slope of this one. Well, let's use our trick. It's going to be 3/4, isn't it? Minus the coefficient of x over the coefficient of y, which means the perpendicular slope is minus 4 over 3. So y minus, I use bracket, x minus, use brackets again, x1. Let's do our math. I am not going to distribute this first of all. I'm not going to distribute this slope. I'll just work out the brackets first, then I'll distribute the slope and make it easier. Y minus 3k minus 1 is equal to minus 4 over 3 on x is 4k plus 2. Now, 3y minus 9k minus 3 is equal to minus 4x plus k minus 8. Let's bring it all together. That's going to be 4x plus 3y. Let's bring the 16s. That's minus 25k plus 5 equals 0. There you go. There's the answer in terms of k. Find the value of, that's that done. Find the value of k for which L2 passes through this point. Okay, let's just substitute the point in, for God's sake, it's not that hard. 4 times, what, 3 plus 3 times 11 minus 25k plus 5 has to be equal to 0. 12 plus 33 is 12 plus 33 minus 25k plus 5 equals 0. 12, that's 45, 50, so k is 2. Okay, not so bad. Okay, hence or otherwise find the coordinates of the foot. I'm assuming what they mean is the point of intersection between L1 to L2. Okay, so let's try and work that out. Now that we know k is 2, we can pop k back up in here and get the equation, can't we? That'd be 4x plus 3y minus 50 plus 5 minus 45 equal to 0. And then the other one was 3x minus 4y plus 10, wasn't it? Let's find the equation. It's one of those ones, isn't it? So multiply the top line by 4, bottom line by 3. And that'll cancel out the y's and solve for the x's type of job. This by 4 is going to give me 16, and 9 is 25x. And this times 4 minus 180. This times 3, 30 is minus 180 plus 30 is minus 150. Bring it across, you get 150. X is 6. If x is 6, y is, x is 6, add 6, 24, 7. Y is 7. So 6 and 7 is the point we're looking for. Okay. And that is it. Okay. There's a sample from the last couple of years of the kind of thing you're going to be coming up with. So listen, go back over this, try them yourself again on your own, see where they're going. Okay. And you should be grand.